This section examines crankcase emission control. While the engine is running, some gases from combustion leak between the piston rings and the cylinder walls down into the crankcase. This leakage is called blow-by. Unburned fuel and water from condensation also find their way into the crankcase and sump. When the engine reaches its full operating temperature, the water and fuel evaporate. To prevent pressure buildup, the crankcase must be ventilated. In older vehicles, crankcase vapors were vented directly to the atmosphere through a breather tube or road draft tube. It was shaped to help draw the vapors from the crankcase as the vehicle was being driven. Modern vehicles are required to direct crankcase breather gases and vapors back into the inlet system to be burned. A common method of doing this is called positive crankcase ventilation, or PCV. A valve called a PCV valve regulates gas flow between the crankcase and the inlet manifold. It is controlled by the pressure in the manifold. With the engine off, the valve is closed and air cannot enter the inlet manifold. This allows the engine to start. At idle, low pressure in the manifold draws the valve to the other end of the body. This lets a small, measured amount of vapor pass the valve. At wider throttle openings, the valve plunger position allows maximum flow through the body, which gives maximum crankcase ventilation. The system is designed to remove more air than just blow-by, so there's a fresh air intake, usually at the air cleaner, to direct filtered air to the crankcase. This intake is usually as far as possible from the PCV valve. Wide throttle openings produce maximum blow-by. Gases that can't be handled through the vacuum system are directed back through the inlet connection to the air cleaner, where they join the carburetor intake air and are drawn into the cylinders for burning.